Bismillahirrahmanirrahim. Assalamualaikum. Hope you're all fine. Topic of atomic and molecular physics, that is the system's energy of hydrogen molecular ion. How hydrogen molecular ion system's energy varies with R. R is the separation variable here. As we know that there are two states possible, symmetric state and antisymmetric state. So for this purpose, first of all, we consider symmetric state. Now here a question arises that why we consider symmetric state first. As we all know that in symmetric state, when we change the state of particles, it does not affect our system. So that's why we consider symmetric state first here, because in symmetric state we have identical particles. Now here we study in symmetric case, we study three types of cases, that when R is very large, when R is approaching to 0, and when R is equals to 0. Let's see what's happened when R is very large, when R is approaching to 0, and when R is equals to 0. Now in first case we see that what happens when R is very large. So when R is very large, then the electron's energy must be minus 13.6 electron volt. As we know that minus 13.6 electron volt is the ground state energy of hydrogen atom. So here we see that when R is very large, then the electron's energy is minus 13.6 electron volt. Here with E, there is a small s in its subscript, so please put small s here. So as we all know that the hydrogen molecular ion is made when two protons share one electron. So we also see the electric potential energy of protons here. So what is the proton's energy, proton's potential energy here? That is up is equals to E square divided by 4 pi epsilon naught r. So now let's see that what happens when R is approaching to infinity, because here we say that R is very large. R is very large, it means that R is approaching to infinity. So when R is approaching to infinity, according to the formula of potential energy, we see that R is in inverse relation with the potential energy. So when R is approaching to infinity, it's mean 1 over R. We all know that 1 over R is equals to 0. So when R is approaching to infinity, then our potential energy of proton falls to 0. And remember that potential energy is a positive quantity, and 1 over infinity is equals to 0. So that's why our potential energy of proton falls to 0. And in second case, when R is approaching to 0, then according to formula of potential energy, we see that R is in inverse relation with potential energy. So when R is approaching to 0, then it's mean 1 over 0 is equals to infinity. So when our R is approaching to 0, then our potential energy of protons falls to infinity, mean it's approaching to infinity. Now in case 3, when R is equals to 0, then the electron's energy must equal that of the helium ion. As we know that in helium ion there are two protons, so that's why they say that here when R is equals to 0, then the electron's energy must be equals to helium ion, that is 4 times greater than the hydrogen atom. So hence we see that the electron's energy here is minus 54.4 electron volts when R is equals to 0. Now here the electron's energy and the potential energy of protons are sketched in the figure as shown. So let's see this figure. In this figure, the curves for ES and UP are shown. So let's see when R is equals to 0, then here it's shown in this fig that when R is equals to 0, then ES means electron's energy is equals to 54.4 electron volt, and the shape of the curve is just like this as shown in this figure, and UP is a positive quantity, so we draw the curve of UP means potential energy of proton on the positive axis. So here we see that the total energy in symmetric case is the sum of electrons energy and potential energy of proton. The total energy has a minimum here, which corresponds to the stable molecular state. The minimum is shown in the figure by a small dip. That dip means here's the energy is minimum. If this point is not clear to all of you, then ask me. I will clear it inshallah again for all of you if it's not clear then. So this small dip means the energy is minimum here, and here the bond's energy is 2.65 electron volts. As we all know that the bond is the energy which is required to break the hydrogen molecular ion into H plus H plus. This relationship is shown here, that is H2 plus ion is converted into H and H plus. So the total energy of hydrogen molecular ion is minus 13.6 electron volt, which is the ground state energy of hydrogen atom, plus the bond's energy, or the dip which is shown here has energy minus 16.3 electron volts. So they say that the total energy is equals to the ground state energy of hydrogen atom plus the bond's energy, or we say that the dip's energy, that is 16.3 electron volt. So this is all about symmetric state. Now let's see what happens in anti-symmetric state when r is approaching to 0 and when r is approaching to infinity. So let's see. Now let's see what's happened in the antisymmetric state of hydrogen molecular ion. So when r is equals to 0 in antisymmetric state, the electron's energy of hydrogen molecular ion is little bit different from the symmetric state. Because in antisymmetric state, when r is equals to 0, then the electron's energy of hydrogen molecular ion is that of the 2p state of helium ion. So in antisymmetric state of hydrogen molecular ion, the bond is only formed when r is equals to 0. Now let's see what's happened when r is approaching to infinity. When r is approaching to infinity, then we just think that the electron's energy is constant, but actually it's not constant. There is a little bit difference. There is a dip which is shown in the figure clearly. There is a dip, which means it's the minimum energy. There's also a minimum energy here, which means that the energy is not constant. However, the dip is not nearly enough to yield a minimum energy in the total energy curve for the antisymmetric state as it is shown clearly in the figure. So that's why we say that in this state no bond is formed. So from the antisymmetric state, we conclude that there is no bond formation when r is approaching to infinity, because we all know that when r is approaching to infinity, then there is no probability of finding electron between the protons. So that's why here we say that when r is approaching to infinity, then there is no bond formation. But when r is equals to 0 in antisymmetric state, then there is a bond formation, but the bond formation here is required enough amount of energy. So that's why we say that the bond formation requires a symmetric wave function. So this last sentence, that the bonding requires symmetric wave function, is a summary of our whole topic, because in symmetric wave function we require minimum amount of energy for bond formation, and we do not face such type of difficulties of enough energy or high energy requirement. So this is all about hydrogen molecular ions total energy, or what we say that it's all about systems energy of hydrogen molecular ion. I hope I try my level best to teach you this topic. If you have any difficulty, then you can ask. Thanks for watching. Allah Hafiz.